Okay, welcome back to Long Distance Learning. Today we're going to be focusing on balancing chemical equations. Their job is to depict the kind of reactants and products and their relative amounts in a reaction. The letters S, G, and L are physical states of the compounds. Chemical reactions occur when bonds between the outermost part of the atoms are formed or broken. Chemical reactions involve changes in matter, the making of new materials with new properties, and also energy changes. Symbols represent elements, formulas describe the compounds, chemical equations describe a chemical reaction. Chemical equations show the conversion of reactants. We're going to have color-coded in red, and that's going to be to the left of the arrow, into products, which are color-coded into blue. Charcoal used in a grill is basically carbon that reacts with oxygen and yields carbon dioxide. Of course, we can put that into an equation. Because of the principle of conservation of matter, an equation must be balanced. It must have the same number of atoms of the same kind on both sides. Symbols that we're going to use, again, S solid, L liquid, G gas, AQ is aqueous solution, and we're going to be using the arrows and the delta as well. Okay, when balancing a chemical reaction, you may add coefficients in front of the compounds to balance the reaction, but you may not change the subscripts. Changing the subscripts changes the compound. Subscripts tell you how many atoms of a particular element are in a compound. The coefficients tell you about the quantity or the number of molecules in the compound. Here's an equation. It tells you 4 aluminum atoms plus 3 oxygen molecules produces 2 molecules of Al2O3. Steps to balancing an equation. There are 4 basic steps when balancing a chemical equation. Number 1, write the correct formula for the reactants and the products. Do not try to balance it. You must write the correct formula first. Number 2, find the number of atoms for each element on the left side. Compare those against the number of atoms of the same element on the right side. Number 3, determine where to place coefficients in front of the formulas so that the left side has the same number of atoms as the right side for each element in order to balance the equation. And finally, number 4, check your answer. The number of atoms on both sides of the equation are now balanced. The coefficients are in the lowest possible whole number ratio, otherwise known as reduced. This slide shows us several different ways of looking at the exact same thing. The reaction, methane reacts with oxygen to yield carbon dioxide and water. Now, it's time to practice. I want you to stop the video, take a look at the equation, and see if you can balance the equation. Okay, if you got it right, you actually put the coefficient of 2 in front of the hydrogen gas and also the liquid water. Now stop the video again and practice on this one. Okay, check your answer. If you got it right, you put a 2 as a coefficient in front of the aluminum and 3 in front of the bromine. Stop the video again. Practice with this equation. And if you got it right, you have a coefficient of 2 in front of the sodium and also the sodium chloride. Okay, stop the video, write this equation down, and see if you can balance it. Make sure you go through each of the 4 steps. Time to check your answer. If you got it right, you put a coefficient of 3 in front of the hydrogen and a 2 in front of the NH3. Okay, let's practice another. Please stop the video, take a look at this equation, see if you can balance it. Check your answer. Did you put a 2 in front of the potassium and a 2 in front of the reactants? Okay, I will see you next time. Long distance learning with the STEM Center.